Assalamualaikum. Hello, hi. Today we study chapter number 4, the derivative in graphing and application, exercise 4.2. In exercise 4.2, we study relative extrema. So, what is relative extrema? Let's suppose we have a function f of x is equal to x cube minus 3x plus 1. Differentiate f of derivative x is equal to 3x square minus 3. So this is first derivative. If I change it, take 3 common, so I have 3x square minus 1 and also 3x minus 1 and x plus 1. This is first derivative x. For critical point, we put f derivative x is equal to 0. Let's suppose 3x square minus 3 is equal to 0. So take 3 common, x square minus 1 is equal to 0, x square minus 1 is equal to 0 and x square is equal to 1. So we have x is equal to plus minus 1. These are the critical points. And what is stationary point? If we put these points in a first derivative and first derivative is equal to 0, so that's these points are our stationary point. Let's suppose x is equal to 1 and x is equal to minus 1 is our critical points. If we put this point in their function, let's suppose I put x is equal to 1 in a function, so I have f of derivative x is equal to 0. It means that x is equal to 1 is our stationary point. And check x is equal to minus 1. If we put x is equal to minus 1 in first derivative, and so this is also for f derivative x is equal to 0. It means that x is equal to minus 1 is also our stationary points. And one thing more, there are two types of test: first derivative test and second derivative test. In the first derivative test, we take first derivative and find point of x, means critical point. Put f derivative x is equal to 0, x is equal to minus 1 by 2. So this is a first derivative test. If I put f derivative x is equal to minus 1 in this function, so f derivative x is equal to 0, so x is equal to minus 1 by 2 is a stationary point. This is first derivative test. And for second derivative test, I take double derivative of this function. F derivative x is equal to 2. F derivative x is equal to 2. It is a constant function. So in first derivative test, when we put x is equal to minus 1 by 2, we have a positive value. Whenever we have a positive value, it means function is relative minima. And whenever we have a negative value, when we put point in a function in a first derivative, in first derivative test, so when we have a negative value, so we have relative maxima for negative value. In second derivative test, we only have a constant value, so we got no relative maxima and no relative minimum, so we have a constant value. Because we have a constant value, now going to exercise question number, starting from question number 7. f of x is equal to 4x 4 minus 16x square plus 17. Differentiate f derivative x 16x cube minus 32x. Put f of derivative x is equal to 0. So we have 16x cube minus 32x is equal to 0. Take 16x common. So we have 2x square minus 2x square minus 1 x square minus 2 is equal to 0. 16x is equal to 0 and x square minus 2 is equal to 0. So x is equal to 0 and x is equal to plus minus under root 2. So these are the points. X is equal to 0 and x is equal to under root 2. If I put x is equal to 0 and x is equal to under root 2 in a function, this function, so I have f derivative x is equal to 0. It means that these critical points are all stationary points. This is a first derivative test. So now for question number 10, question number 7 to 14, we just tell the critical points and stationary points. Next question is question number 10. F of x is equal to x square divided by x cube plus 8. Take derivative, f derivative x is equal to x cube plus 8 square x cube plus 8 2x minus x square 3x square 2x 4 plus 16x minus so this is f derivative x. Put f derivative x is equal to 0. So we have minus x4 plus 16x divided by x cube plus 8 square is equal to 0. Divide, multiply both sides, x cube plus 8 square. So we have minus x4 plus 16x is equal to 0. Take x common. So x is equal to 0 and x cube is equal to 16. There, if we apply cube root on both sides, so we have x is equal to 0 and this value x is equal to 2 4 by 3. If I put x is equal to 0 in a function, this is a function x, f derivative x. So I have f derivative x is equal to 0 means I have a positive value, so this is relative, it is relative maxima, but we only tell about the critical stationary point. When we put x is equal to 0, so f derivative x is equal to 0, so x is equal to 0 or stationary point. Now we go for the question number 25. In question number 25, use the given derivative to find all critical points and at each critical point determine whether a relative maximum, relative minimum, or other or neither occurs. Let's suppose we have a function f derivative x. We have a given f derivative x is equal to x square x cube minus 5. So f derivative x we have a given. So we find put f derivative x is equal to 0. So x square is equal to 0 and x cube is equal to 5, x is equal to 0 and x is equal to 5, 1 by 3. For relative maxima and minima, put these points in a function. If I put f derivative x is equal to 0, so I have a positive value. It means that this function is relative minima. Next function is x is equal to 5, 1 by 3. If I put 5, 2 by 3, 3, so we also have a positive value when we put x is equal to 5, 1 by 3, so it is also relative minima. This is the first derivative test. Now if we go for the second derivative test, let us question number 33. F of x is equal to 1 plus 8x minus 3x squared. Take first derivative. Put f derivative x is equal to 0. So x is equal to, we have 4 by 3. These are the points from first derivative. Take double derivative, f derivative x. So we have only minus 6. So f derivative we have in f second derivative we have a constant value. So there is no relative minima and maxima because we only have a constant value. We don't have a variable. So that's why it is a constant. Next question is question number 34 from second derivative test. Take derivative 4x cube minus 36 x square. Put f derivative x is equal to 0. Take 4x square common. So we have x minus 9 equal to 0. X is equal to 0. X is equal to 9. These are the points. Take double derivative. 12 x square minus 62 x. So this point put in double derivative. Put x is equal to 0 in a double derivative. Double derivative x is equal to 0. So we have a 0 means some positive value, so it is our relative minima. Now put x is equal to -9 in double derivative. If we solve that, so we have a negative positive value, so it means it is also we have a relative minima. And question number 37 is that use any method to find the relative extrema of the function. Question number 37. F of x is equal to x4 minus 4x cubed plus 4x square. If we take single derivative of derivative x is equal to 4x cubed 12x square plus 8x. Product derivative x is equal to 0. So we have 4x cubed 12x square plus 8x is equal to 0. Take x is equal to common. So we have 4. Take 4x common, so we have x square minus 3x plus 2 is equal to 0. So x is equal to 0 and x square minus 3x plus 2 is equal to 0. Now midterm break. X is equal to 2 and x is equal to 1. These are the 3 points for relative maxima and minima. We put this point in a function in a first derivative. We put x is equal to 0, so we have only 0. It's mean in at x is equal to 0 relative maxima, relative minima. Now x is equal to 2 when we put x is equal to 2 in a function. Derivative x is equal to 4, 8, 12, 4, 16. We have a 0, so add x is equal to 2 relative minima because we have a positive value. At x is equal to 1, output x is equal to 1 in a first derivative. 4, so we also have a positive value, which means that at x is equal to 1 relative minima. So that's for today. If you can't attempt any question from this exercise, contact us on Facebook and Insta page, and for more information also join us on Facebook and Insta. The link of Facebook and Insta page is in description.